All right, let's jump right into this explainer. Today, we're decoding what is honestly the most empowering language of everyday life and finance. We are talking about percentages. Too often people view percentages as just this set of dry math rules you leave behind after graduation. But the truth, they're the absolute foundation of how we navigate the world, from the discounts we hunt for, to the taxes we pay, to how our wealth can actually grow over time. Let's uncover how a few simple tricks can completely transform the way we see these numbers together. So, here's our roadmap. We're going to start with the power of 100, meet your secret weapon, tackle reverse and successive changes, dive into compound growth and decay, and wrap up with exam strategies and traps. Let's get to it. Section 1, the power of 100, setting the baseline. The word percentage literally just means out of 100. It's brilliant, really, because it gives us this universal baseline. By locking 100 as the standard, we can compare totally different quantities on an entirely level playing field. Whether we're talking about exam marks, your next big salary bump, company profits, or even global population shifts, this one single concept is literally the engine running the whole show. Think about a number like 25%. Thanks to that out of 100 rule, it perfectly translates to exactly 25 parts out of every 100. And mathematically, we can seamlessly express that as the decimal 0.25. It's the exact same value, just, dressed in different clothes for different occasions. Fractions, decimals, and percentages, they're really just different dialects of the exact same mathematical language. Translating between them is a total breeze. Going from a decimal to a percentage? Just multiply by 100. Going backward? Divide by 100. Once you're fluent in this, you can do things like find 15% of 200 just by multiplying 200 by the fraction 15 over 100. Boom, you get 30. Easy. Section 2. Meet your secret weapon, the multiplier. Okay, enter the multiplier method. Most people, maybe even you, use this slow, clunky two-step process. They find the percentage piece first, and then add it back to or subtract it from the original number. The multiplier method completely skips that middleman. By taking the number 1, which represents 100% of your original value, and just adding or subtracting your percentage as a decimal, you get a single magic number. You multiply once, and you are straight to the answer. It's a real game changer. Let's look at growth for a second. If a 400 rupee book jumps to 500 rupees, finding the difference tells us it's a 25% increase. But if you already know you want to add 20% to something, say a tip at a restaurant or a tax, your secret weapon is just multiplying the original value by 1.20. That 1 keeps your original amount perfectly intact, while the 0.20 seamlessly adds the increase. And this perfectly sets up the flip side, a decrease. If a 2,000 rupee jacket drops to 1,600, well, that's a 20% drop. With our new method, decreasing by 20% means multiplying by 0.80. You're literally just doing 1 minus 0.20. Now, listen closely here. A 20% decrease uses 0.80, but a 20% increase uses 1.20. They're related, absolutely, but they are definitely not just direct opposites of each other. Section 3. Reverse and successive changes. All right, welcome to our first real boss battle, the reverse percentage. This is where you know the final value, and you have to sort of reverse engineer the starting point. The golden rule here, never ever just subtract the percentage from the final value. Instead, you divide the final value by your multiplier. So if a bag costs 600 rupees after a 20% increase, you don't subtract 20% from 600. No way. You divide 600 by your 1.20 multiplier. Do that, and it reveals the true original price, 500 rupees. So what happens when we handle multiple changes in a row? Let's bust a massive retail myth right now. When a store advertises a 10% discount plus an extra 5% off at the register, that does not equal a 15% discount. Successive percentages actually apply to the new value each time, not the original starting price. You absolutely have to combine the multipliers. In this case, 0.90 times 0.95. Let's put this into perspective with a 20,000 rupee phone. If you just naively took 15% off the 20,000, you'd probably expect to pay 17,000 rupees. But when we use the correct successive multipliers, multiplying by 0.90 and then by 0.95, you actually end up with 17,100 rupees. Combining those discounts upfront in your head literally costs you money, because that second 5% discount is only being applied to the already reduced price, not the full 20 grand. Section 4. Compound growth and decay, time and money. Now we hit the compound formula. I know, it looks a little technical, but really, it's just our multiplier method put on repeat. When a quantity increases or decreases repeatedly by the exact same percentage over multiple periods, like years for instance, it creates this massive snowball effect. You just take your original amount, multiply it by your multiplier, and use an exponent to represent the number of time periods. You can really see how the value starts accelerating the longer it sits. If you were to invest 10,000 rupees at a 5% compound growth rate every year, you'd calculate 10,000 times 1.05 to the power of 3. After 3 years, that money has naturally grown to 11,576 rupees and 25 paise. The multiplier is literally doing all the heavy lifting for you while you sit back and wait. Now, let's look at how this spells when things go the other way: compound decay. We apply the exact same multiplier logic here, just using our decrease rule. Say you have a 60,000 rupee laptop that loses 10% of its value every single year. That uses a 0.90 multiplier. To find its value after 2 years, you just do 60,000 times 0.90 squared. In just 24 short months, that expensive piece of tech has plummeted to 48,600 rupees. It's also super important to realize that everyday taxes, like GST or VAT, are really just another form of this multiplier. If you have an 18% GST on an 800 rupee product, you just use an increase multiplier of 1.18. 800 times 1.18 gives you your final register price of 944 rupees. It's beautifully consistent across the board. Section 5, Exam Strategy and Traps. Okay, let's confidently march through a 4-step strategy that works pretty much universally. Step 1, always, identify your starting original value. Step 2, figure out the type of change. Are we talking growth, a discount, maybe a tax? Step 3, craft your secret weapon, the correct multiplier. And step 4, apply the operation. Multiply for a normal forward change or divide if you're working backwards with a reverse percentage. And here's a rapid-fire list of the absolute most common pitfalls to avoid. First, never add successive discounts directly together. Second, always anchor your percentage change back to the original starting value. Third, don't ever try to guess a reverse percentage by subtracting. Always divide by the multiplier. And finally, treating a 20% increase and a 20% decrease as equal opposites, that is a fatal flaw. They are 1.20 and 0.80. They behave totally differently. Which brings us to the core takeaway of this entire explainer. Percentages are not just arithmetic. They are the language of comparison, finance, growth, discount, tax, and real-life decision-making. By mastering these multipliers, you are quite literally decoding the world around you. So, I'll leave you with a quick question to ponder. The very next time you go shopping or check a bank statement or see a flashy double discount sign in a store window, are you going to let those numbers control you, or are you going to use your multiplier to take absolute charge? Thanks so much for exploring this with us, and keep these strategies in your back pocket to stay sharp out there.